Hello everyone, this is Charles Dyson from Marathon College of Engineering and Technology of Civil Department. So today we'll see about the topic of fold and fault in from engineering geology. So fold. So fold is undulation or bend or curves developed in the rock on the crust. On the crust. So it's the rocks whichever is present above the surface of the earth. So here you can clearly see the bends of the on the rock that has been formed due to the stresses that is being formed during the formation, which I have already explained in the previous slide, like a previous topic. So formation of rocks. So during that formation process, when stress acts on it, so undulation or bends will be created on these rocks. So with this geometric elements of fold, you have got a few geometric elements: fold hinge, then fold plane, hinge zone, fold limb, fold axial plane. So here you can see the profile plane which divides the limbs into two equal parts. Then fold axis which comes to runs on the limb. So you have got two limbs, one limb, and this is another limb. So hinge is the topmost layer, and the whole area is known as hinge area. So classification of folds. So you have got anticlines or syncline. So the previous slide when we saw about the picture, we saw the picture. You have got like anticline over there, and syncline is when it's reversed. It's known as a syncline. When the limbs are upwards, you term it as synclines, and when the limbs are downwards, so two limbs here. When the limbs are downwards, you term it as anticline. So here's a picture. So with this position of axial plane, you have got symmetrical fold, asymmetrical fold, and overturn fold. Symmetrical fold here with the axial plane. So when both the limbs are equal, you call it as symmetrical fold. When both the limbs are unequal, here you can see a shorter limb and a longer limb. So it is called asymmetrical fold. And when both the limbs are on equal side of equal length, you call it as symmetrical fold. So overturn fold, that's like a horizontal one or a recumbent fold. So fan fold, when you see the limbs like it's being created like a fan, it's curved too much and it's created like a fan, and you call it as a fan fold. And isoclinal fold, the limbs are dipping in the same direction. Here you can see almost in the same direction. It's not of the same, even if it's not of the same direction, like almost of the same direction. When both the limbs are inclined in the same direction, you call it as isoclinal fold. And recumbent fold, you have got a picture of it. Recumbent fold, see both the limbs, it's in a horizontal plane. So see here you can see this black line which is in a horizontal one. Almost both the limbs, first limb and the second limb, both are of inclined one, almost sorry, horizontal one. So you call it as recumbent fold. Then conjugate fold, when pair of fold mutually inclined axial plane, when it's present in the mutually acting axial plane, I call it as a conjugate fold. Then box folds, so flat top, if it contains a flat top, you call it as a box fold. So box folds are again divided into two types: open box fold and closed box fold. When this area is closed, you call it as a closed box fold, and this one is known as your open box fold. So mode of occurrence, you have an anticlinorium, then synclinorium, dome, and basins. With the position of axis, you call it as plunging fold and non-plunging folds. Behavior with the depth behavior, you have few types like a concentric fold, similar fold, superaceous fold, and a monoclinic fold. Then homocline and tract fold. The next one is fault. We'll see about the next topic, fault. Here, fault is a fracture along which there has been relative displacement. So the previous one, fold, it's undulation on the rock. Here it's a fracture, broken surface on the rock. Here you can see this surface, the grain, how much it has moved. You can see this part here, it comes here and here, almost it moved, and a fracture has been created here. So a displacement, you can see it in this animation, how it gets displaced, it breaks down and slides down. So it gets slide past one another. The blocks slide past one another, and during this process. So fall zone, shear zone. So you got dip, head, the wall, slip. So classification of fault. So based on apparent movement, the relation of fault attitude, direction of slip, amount of dip of the fault, and mode of occurrence. You have got you can classify this faults. Due to apparent movement, you have got normal fault, gravity fault, Horst and carbon. So Horst is the topmost one. So you can see here, this is a Horst. Then this is carbon. This area is not carbon. Here you can see this carbon. And slipping past one another, this blocks here, this and this blocks slips here. So here, this you can see it clearly. This dotted points, this one is moving upwards, and here it's moving downwards, and it is known as normal fault. So carbon, the lower this one is carbon. Then when the slip moves upwards, it's known as Horst, and when it pass one another, this pass one another, you call it as normal fault. So here normal fault when it passes one another. So all three faults, there is gravity fault, Horst and carbon, it's shown in this pictorial representation, and in the animation you have got this is carbon, Horst, and normal fault. So you got a reverse fault when it moves in an opposite direction. The blocks moves in an opposite direction with a inclined zone. So attitude of fault. With the attitude, you can again divide it into strike fault, dip fault, oblique fault, hinge fault, parallel fault, peripheral fault, and radial fault. Here are a few pictures of it.